morning, sir. 1 2 1 1 1.
No, I have taken it.
This is the flow of the presentation. My problem statement is to design and implement a method or an algorithm to extract region of interest in a finger-knuckle print image.
So that means you are looking for automatic ROI.
Yes.
Automatic ROI.
Yes.
Right? I will give you the figure back side of the things you will be detecting.
Yes.
Right?
Yes.
Now the condition is I have to extract. Is it
This is only the finger-knuckle print.
how are you going to get the image?
So that's what I will explain.
Image.
Image is from a database which we have.
So what is the limitation is that it will be horizontal.
It is horizontal because there is a device which is being used.
Device is a flatbed scanner.
No, sir. I will show you the device.
Okay.
Should I cover this or can I skip it?
No, these are not required. Why you find out
This is the device which they used it in a Hong Kong.
I don't have this device.
But our database is from this.
You want to, but how are you going to useful for us?
Sir,
You want to purchase this?
not purchase the similar type of device we also think to make. Similar type of device. He
You want to make the device?
No.
It is like that the scanner that they are using, the images that they have given the full images of the finger. I have given that to him starting point, and the limitation I think is algorithm will be that he requires images like the horizontal images. So if we somehow manage to get images like this or horizontal images or even like this and place the camera over this point, then his algorithm will also work.
Is it okay?
Yes.
So what should we, so you must tell what is the PPI.
Yes.
Your PPI you have to tell. The scanner specification.
Yes.
Will it work on flatbed scanner? Simple flatbed scanner, I put my hand like this. Will it work in your case?
Yes.
No, see what if you place your fingers on flatbed scanner like this, then you'll have to press a lot, and even after that you are not able to get better images. So in place of that, what you can do is that place fingers like this and take an image at a distance, and then you can say that it will work on that.
So in the paper which they give us, sir, what they are saying is that if it is straight, then we are
No,
not
no,
getting.
but see, if you use this scanner device, I don't have any problem.
Yes.
Then we have to procure this scanner
Yes.
so that we can use it. Right?
Yes.
But if you cannot use, because otherwise it will not be useful. Is it because you have to depend on their database.
Yes.
You understood?
Yes.
So you decide. If you feel that no, sir, scanner is this one, you will go for that. If you feel no, sir, I want to test on flatbed scanner where PPI is 250, very low resolution, right?
Yes.
Or you want, no sir, I want different type of, say, IR base, like all those things you can
So the
take.
image which they are supplying.
You want, now your aim is that on this
For-
scanner.
for this
It
image.
should work on this
Yes.
scanner. Am I right?
Yes.
Okay.
The
Take
scanner
it.
which they use, sir, it is
Take
150 ppm.
150.
150 ppm. So now my approach was that first to implement the already existing paper that I implemented. Then with that knowledge I
You have implemented.
Yes. So these are the 6 steps which they have proposed in their paper. From Dr. Zhu and Zhang. So these are the 6 steps which we have got. What they have done is that they have taken this tiny edge image. From this they calculated this line that is on the device where the finger is resting. Then empirically they cropped it. With this image again they applied tiny edge. Then after not tiny again they applied a tiny edge. Then what they have done is that they have seen this curvature and they applied weightage for this curvature. That is, if it is convex outward and convex inside, they have given -1 and +1 as values. Then what they have done is they have run a loop to check the value. What they are saying is that at certain point this weightage will be minimum because the one side it will be convex, this side,
Yeah.
other side it will be there.
Right.
So that they are taken as central axis and they taken it as if it is this central axis then 110 on this side and 110 pixels on this side.
Okay.
So total the ROI which they extracted is that 110 into 202.
Okay.
But while implementing this, I have found out that when they get this axis is not always in the center of the image.
Okay.
So, but that part is not clear that how they have taken this 110 now. Either they have taken it on each side or
that is your experience.
so my approach was that since the quality of the image is good in the sense that all these images samples which we have got, they are from the same device, so they are lying on the same bed, and the image is more or less like this with the fingers shining. So now my aim was to take 4 axes, bottom, top, and vertical both the axes. If I can crop it at that place, then I can use this ROI. Now since the quality of the image is good, what I can do is that I wanted to try an empirical one so that there is no computation. I get some numbers for these values and I can pass the thing as it is. That was my aim initially.
See, if you know the scanner is with you,
Yes.
and I can always make a point on the scanner where this one will be.
Yes. It is there, sir. The
So
triangle.
if it is there, if you know the center, then that is your center.
Yes.
Then why so much canning and other things are required? If I know that this is my center, it takes straight away. Only you need to know the bottom axis and top axis.
Yes, that was my initial design. That's how I proceeded. So first I started with the bottom axis. What I done is I applied KNUCKLE data, then got the run the loop and get the maximum summation in the horizontal axis. Take that axis. So now that I run for this is the code in MATLAB. Now once I run for these 12 images which I got initially. So this was the same. These are the images. This is dynamical loaded and this is the cropped image. So I get this cropped image like this. Now when I take average of these rows, these are 12 images. Then I average that is 252. So now I fix this line as 252. Like the original image is from 1 to 288 and widthwise it is 1 to 384. So in the 252 I fixed it. Then for the top axis again same thing. But now here I considered only that when I take that image, if I run this thing then again there will be, it is not guaranteed that I will get the maximum this thing summation at the top thing. But seeing the image I can make it out that it is in the second quarter. That it is in the second quarter of the image. So I run it from second quarter, 72 to 144. So I am getting, then I sum this thing. Now again this is the top. This is the top crop. The 12 images which I have. The average of 12 I get 128 as well. So finding the y-axis. Initially what I thought is that the image which is there, that they kept it as a bent image. The camera which is scanning, it is able to focus on this area, but this difference in depth which is there, that it is not able to catch. There is a blur and out of focus image on both the sides. So initially I tried with just cropping on each side 10% or 20%. It worked, but there is a code for that. It worked, but the problem is that like sometimes that it is not clear here in the picture. The finger knuckle which is there, sometimes it is on the slightly on the left or right side. So then I am losing out the data if I crop it like this. So initially my approach was this, that I will just make these 4 lines which are there, values, and we can, without any computation, we can just crop the images which are there. But then this vertical axis has been a problem. This is how 10% and 20% cropped images for 12 images I got. So then I had to use this pixel intensity which is there. Because the camera which is there, the phalangeal joint is facing the camera and the light, LED lights. So there is a brightness at the center. So I try to use this. So again taking this is the code for us. Again taking the maximum magnitude of this thing. I got this central axis like this. Now taking central axis and again I tried to do like what they have done in the paper, taking the axis on 110 pixels on each side. But I felt that 110 pixels I am losing out some data, so I made it as 120 on each side. So it is like 128 to 52 and this is the size here. So this is already existing algorithm. here we have to run that entire loop for twice KNUCKLE gesture and once for this convex weightage addition on this. So that is very high competition. Empirical method we can just crop it by 20% or so, but it is not good. There is no competition involved. There is a size 125 into 233 is a ROE image. Using pixel intensity, I am using this as the size 125 to 241. But here only competition is that only once I have to run the loop for getting the intensity.
No, but in that case, what you are losing if I use the empirical method?
Yes.
You are not losing much.
Not much, sir, but only thing is that sometimes that if the finger knuckle is not centered exactly, then I am losing that
Some area
I am losing in the 20%. And if I am using only 10%, then it will be size will be very much. And in other images there will be a lot of area which will not be used for our competition.
No, the issue for me is that I put the finger like this.
Yes.
Second time I will be putting little back, not the finger. Third time I am giving the full link back.
So the devices like the such as things that in this
There
device there
is no restriction.
no, so there is a triangle sort of thing here.
What
Which
there is an inside hard.
yes, and this is hard thing, and it is all fixed. The distance, everything is fixed. Now the person has to keep his finger, and where the phalangeal joint is touched, that will come on this vertex. So that's why the quality of images which you have got is very good. Like,
And then they will be projecting this triangular one
yes.
onto the plane.
This is the camera. Inside there is a camera.
But now this is, see, this is a center. You are
Yes.
getting full intensity here.
Yes.
Here you are getting less because it is a
Depth is different. Yes.
yes. So what do? You is there any requirement of
No, sir, not required.
projection?
No, sir, not required. Because sir, the image which we are getting, it is like this. So in this area it is focused. Like in projected it is not clear, but then it is clear in whatever ROE we are extracting. There it is all focused. Only at these places it is not focused. It is not focused.
No, but are you, if you do not project it, are you getting the better result?
Yes, the thing is that they are not using the rest of the parts.
Can you think about that one also? That they need to project on the.
It can be done, but what I was suggesting to him is that we have one approach where the images are cropped ROI from the poly data, poly persons themselves. He has also done the cropping, and there is empirical cropping. So these are three different croppings, and we have some recognition and several recognition algorithms they are developing. So we use one recognition algorithm on the crop all these three different croppings, and then yes, I just wanted to compare how your algorithm is working, the segmentation algorithm is working, and how the poly the own algorithms is working. If it is same, then that's the thing is that I wanted it in a different way. So now he is finding out that center line in a different way than the convex coding done by them.
So you will be able to do it, right?
Yes.
1.70?
So sir, I am doing the automatic no step detection. The problem statement is to automatically detect no step without any training information on 2D images, cropped images only, and main thing is that most of the images are frontal images, so I will use it like that. The approach is first I take the complete.
What is adapted approach?
What I am choosing.
Adapt, no adopt. Adopt. Okay,
So I'll be taking the whole image and I'll be collecting the candidates by whoever have the highest intensity as compared to the neighbors. So that will be my first step to take the candidates.
So that is a proven one, right?
Yeah.
That those will have
The
most
higher intensity as compared to the neighbors.
That is a
So then I will use a threshold, and since all the intensity of the neighbor should be equal, so variance should be small. For example, this is the no step and these are the neighbors. These neighbors will have almost equal intensity, so their variance will be less. So I will be using that threshold also and limit on the variance to decrease my number of candidates.
Now, you draw a face.
Yeah, I'll be showing you an example.
No, I am giving you a draw a face with a tumor here. Okay, draw it. Tumor is tumor. Bone. Nose. You draw a nose also. And somewhere you put a tumor. Now you tell me the intensity will be high on the tumor also?
Yeah, it doesn't matter.
So then how are you going to detect that it is nose tip? That will
Nose tip will be detected by the center of the image. And you just
so estimated area also will be taken into account. And
after the threshold and the variance, I'll choose the. I have to ignore this this area and cheese. So I'll be selecting a circle of radius r at the center of the image that will keep the nose area. And then after that, I'll choose the highest intensity pixel in that nose area that will be reported as the nose tip. So this is the example. This is a given image. I'll reduce the candidates, then on threshold and variance, then this will be the nose area, and this is the highest intensity reported pixel.
so it is coming almost
85%.
What about can you show me the result of where it failed?
Wow.
Where it failed?
It fails. Actually, it's not exactly at the center in some cases due to the angle shift of the image. It's facing like this.
Pose.
Yeah, pose. Angle of the face.
Not this. This is also an angular one.
This is little angular.
Huh?
This is not that much angular.
No, this is like this.
No, not angular in this. Angular in this sense. 3D.
Okay.
The nose will be. Because of the light coming here, then it will be shifted here. So for that, I am trying to convert this image, invert this image, and reduce the nose tip area more, so that I will.
Right. Tell me one thing, that if I do not put the light source from the front,
Okay.
will it work? If I
Then
put it from the side?
No.
Assumption fails that the nose.
Nose has high intensity. That means that the light is coming
From the front only. So that limitation you have. Okay. Okay.
Only work in the frontal images and
Light source will be from the
from.
So you note down these limitations, because this is required for it. Okay.
Yes, I've done some reading work. Now
Reading what? What is that?
I was going to 3D indexing images.
It's a previous whatever you have told, that is non-reading one.
Yeah.
Without reading you have done that.
Which one, sir?
Previous last few slides you have shown. What is done?
I'm just listing out. Actually, he has given us a layout, not that.
What? Reading one there, okay?
I have said that whatever you have read, you also because several students are there who only read.
So what is your reading one?
Reading I done on 3D base,
3D face will be easy.
So I use that concept in that sense that they're using the concept of energy there.
Exactly.
I'm using the concept of intensity here. And the rest thing is same because the nose area and all that.
That component you will be. Right? For 3D it will not be very difficult. If the assumption is that there is only one peak point. There are some people, they may have the nose with the two.
But then average.
Like this.
Average.
Very good. So those things also you must take care of.
These are some example images.
Where you are successful.
Yeah. It works for people with spectacles also. All light images and light, some dull images.
As far as nose is the brightest one. In the
I mean,
center.
just you have to click the photograph on the plan. Rest the artist taking.
A light source should have to be there.
Light
Sometimes we say that image is taken without light source. So there it won't work. Assumption is that nose is the brightest part and in the center.
At the center of the video.
So So you just immediately talk to Uma and give your previous picture.
Actually, she suggested to increase the accuracy.
Yes, that also will be there. And at the same time, what I want, we have you have that IP database, right?
Yes.
So you can give it also the code for testing on, but don't give him the photographs.
Okay.
Or sit with him and test on, that where there is a large database where you can test more better way.
Those
Grayscale.
No color, you make it gray? Oh, their photograph is not only gray, there are some photographs, nothing is visible, don't worry, all sorts of things is there. Okay? Who is coming there?
So this to extract ROE from a force lap
Right?
force lap finger. This is what with the paper which Aditya has given me, how they have done it.
Visual one.
So the first step, it is not clear in this. The first step is this original image. He has binarized and downsized it, and the rotated. He has rotated 19 images rotated, and he found out what is the orientation of the image.
It is not only binary, it is also negation.
Concept?
Negation.
Yes,
Negation plus.
inverted image.
Okay.
And he has found out the clusters. Clusters, and there is a box here. It's not visible in this. So he has found out clusters. Like if there are adjacent by neighborhood, he has found out the clusters, and all these things have come in one cluster. So this entire thing is in one box, and then he had validated the boxes depending upon applying a threshold. That's what we are doing. My approach is also initial similar downsize it.
No, but what is the problem with the previous method?
Previous method there was getting there are some overlapping, like exact this line was not getting. That's what Aditya told.
That is the only
Problem was that
only
this-
problem.
There are
See, let me tell you, the problems you face with this method, first one is that we are assuming there exist all four fingers. Right? But it has been observed 5% of Indian population, they have one finger missing. This is first part. It takes a lot of time. Second problem we face. Third problem is that if the two fingers are overlapped, the problem fails. Are you taking care of all of that? Or one of them?
this
Or none of them?
no sir. When this algorithm will be faster than this,
Time will be
Yes,
saving
sir.
time.
Yes.
Okay? That also we need.
and this overlapping is a problem. I am not able
This
to-
overlapping you are doing. If one finger is missing,
that passive now I am not getting, but it is possible.
so these are the major issues at that time. Overlapped the fingers and one finger is missing.
So overlap finger even
and also the knuckle line.
Knuckle line.
yes. Like knuckle line I am getting exactly.
Knuckle line is required only for the cropping purpose.
Yes.
Okay?
So I'll with the diagram, this is the image and binarized and downscale and initially I like last time I had explained, I scan it row wise and summing up the intensities column wise, and whenever I get a zero intensity I take it to the start of the finger. So that is this way, like.
Okay.
And then each column, this column I start to scan this way, and I'll get the start of the finger and intensity. I'll just show the finger intensity value, something of this sort. This is the start of the finger, and it reduces. There is a variation. So I need to find this. This is the exact point of the knuckle point. So and I'm able to this 5. I've just tested it only on 5.
What is the time difference between your method and Nishan?
Sir, I go only maximum is mn, sir, but in the other method, exactly I have not calculated.
See, M and N, all those things I don't need. I need that I will put an input, you estimate the check the time, what is the output?
Testing is required. Also, you have to test it on bigger database.
Bigger
Then
database.
you report what is the segmentation accuracy and compare it with the Nishant one. Places where you are not getting the knuckle lines. I mean, rigorous testing is required. You have just made. You have to tweak this some parameters. Some more things you will have to add. So now you have to work on the big all that.
This is actually, if you can save some time, that will help us. Even if it is a forefinger, you are issuing forefinger, no problem. But time is the critical problem. You spend, it takes a lot of time in our case.
While
Check the time, check the time.
That is the critical thing. So you just check that Nishant's one, how much time it's taking. You meet within the Meena.
yes,
You know Meena?
I'm
I-
doing but yet.
I have a question. On which operating system this is working?
This
It is a Windows based or Linux based?
No, I did it on a Windows based in MATLAB.
Did it on Windows based?
So you work on any operating system.
Nishant's doesn't work on Windows. It's a Linux.
Nishant thing actually use the NIST
Yeah.
routine. So NIST, that is the
That is what
quality
is
and
actually increasing
quality
the
and
time.
matching.
Yeah.
Segmentation works on Windows or Linux or whatever.
Okay.
That is why it's not working because it uses binaries of Linux.
No, if it is a Windows, that also will help.
It is operating.
If you can,
We have to
But
finally
limits can directly be
embed
plugged
all
in.
the systems. Finally, we have to embed all the systems.
So it is directly. Nishant one is also directly, but the segmentation, only segmentation parts.
Yes, sir.
Good morning, Mr. My term paper is on iris recognition, and I will be using efficient iris recognition by characterizing key local variations in the iris part. This is my paper, and the approach to implement this paper is I am going to get up to normalized image, and I have got the data from Aditya. And after that, I will generate a set of 1D signals from the given data, and I will extract the feature from that, and I am going to match that. This is the whole part of the implementation of my paper. And the 1D, I have generated the 1D signal, and the concept used in this paper was generally in iris. Taking after the pictures, generally some occlusion occurs, and so in that paper they have considered only 78% of the portion is after getting the normalized image. This circular part is converted into a rectangular strip. So in that paper they have taken 78% of the total rows of this. Is enough, more than enough to extract the features from that image. So the signal generation is S is equals to, they have taken 1 by m of sigma. For given image contains 64 cross 256. So my signal 1 will take a summation of 1 by 5. I have bunched the given images into averaging into 5 rows. Divided first 5 rows I have accumulated it and divided by 5. So S of 1 will take I1, I2, I3, I4 plus I5 up to I5. I feel that S of 10 will take I46 plus I47 till I50. So out of 64 given rows, I have considered 50 of them, and I have generated the signal, and I have got a signal matrix. On the signal matrix, I have applied a wavelet transformation. I had extracted the feature vector out of it.
Up to this you have done.
Yeah, up to this.
Up to this you have done.
We generated the signal and applied a Euler transformation and extracted the feature vector. Till this point.
But if you make it average, are you not using the texture?
This the main thing is there are the key local variations in that. So in the wavelet transformation, we have using the concept of maxima and minima. So if there is any key variation, while seeing that there exists first one minima should occur and then one maxima should occur. That thing I will in future I am taking care of.
You take care.
And faint things.
5 rows you have taken.
Yes, sir.
And my texture, 5 rows is a big number. Texture will be within 5 rows.
Yes, sir.
Take the average.
Faint things I am eliminating the faint variations where there is in
I
feature.
don't know. You check that one whether you are using the information. Most probably, my feeling is that if you take the 5 rows, averaging it.
Okay, sir. We check.
The big 5 rows will be for an iris, 5 rows is a big number.
They have given the value this 5 or you have chosen?
They have given the 5 and they have set the values 10 signals and 5 averaging up to 5.
10 one-dimensional signal.
Yes, sir. And final matrix we are going to get is 10 cross.
These are they have tested using several different values and
Then they got
M they have taken as 10, M they have taken as 2. And these are the papers related to that. The rotation part, as you asked in the class last time, since I am taking rotation part, I will bit rotated. Then the rotation is equivalent to translation in that. You translate this bit and shift it and match it. I will.
you have got the database.
I have got the database and I have completed up to the feature.
Now you have to match.
I will have to match and that rotation.
The
IITK data from Vamshi.
And AC and both of these.
Uh,
Test on all the data.
Okay, I will test.
Because once you have completed this, then fine tuning and this reality scaling, what that will be done.
Okay.
See, our database is better. See, 4, right? On our database.
Okay.
Then you one find there is some of our database online.
And my area of working is post-lab fingerprint recognition.
Okay, so what you have done?
Sir, I was given segmented images.
Given segmented.
Given segmented images.
Okay.
Test.
So 4 fingerprints will be getting.
4 fingerprints I'm getting. And problem I got is, first of all, I used the minutia points, the distant algorithm.
List minutia.
List minutia points, but I am not getting all the features from the list. It is returning only the quality, the coordinates of the minutia points and orientation of each minutia point. But I also need the number of ridges between 2 minutia points and which kind of minutia point. Given it is not returning.
Normal thing there will be. The 4 parameters you will get x, y,
X.
theta and time. This 4
Theta
parameters.
and
Time is also there.
it's,
Whether it is a bifurcation point or transition.
someone told me that it is quality.
Huh?
Someone told me that it is quality. That's why I didn't.
Who is someone?
Vikram.
Who told you to build Vikram?
No, I minutia.
Vikram gave you the wrong drawing.
I thought it is faulty, and then so I have used my I have modified the algorithm to get the ridges, the number of ridges between two minutia points, and even two minutia points. I was having a normal grayscale image, so I have converted to binary image, and then I have reduced to each will have only single pixel at max. I reduce the size of the edge from some endpoints to 1 point. Okay. Then I calculated the number of edges existing between two minutia points, and this is one of my feature. And some features I have like orientation between difference between these two features. And again, in my algorithm, what I need is nearest neighbors of each minutia point. I have done
Suppose there are five minutia points. Draw a gola. Write 5 and another gola. You draw the 4 minutia points. Now, this is the same fingerprint.
Yes.
But 2 instances are taken. And out of these 2, 3 of them are found. Right? And 2 of them are not detected by the second one. One of them is a new true minutia point. Now, how you are thinking that will work?
So actually, Alchi has given me 2 papers, and one paper is not considering what you have told, example, and the second paper is taking care of that thing. I mean, there are some minutia points which are not present in first image, and then there are some minutia points, newly added minutia points in the input image. Then they are ignoring the new points. And one more thing they are taking care of is some minutia points are lying inside the region of interest in existing image, but some may be out of the region of interest in the input image. Suppose there is a minutia point here, and this image also has a, this image is taken fingerprint like rotated, and then you will not get this minutia point here. So, and similarly you will find some minutia points existing, but this may be the out of this region. So what we while calculating the score, we are actually given some weightages, and also
Not getting.
sir,
Not getting.
if you are taking fingerprint from straightforward, sir, you will get some, you will get more minutia points, and when fingerprint is given somewhat tilted.
You want to do that one? Tilted value that type of problem you want to solve?
Yes, sir. Actually, it is taking care of that in the second
No,
time.
no, you want to solve that problem. Answer you. Who is taking care of it? You want to try.
I am trying that.
You want to try for that. But then why you are thinking about the 4 slab and other things?
Sir?
4 slab fingerprint. Why you are thinking? You are taking a single fingerprint, which is not fully cast, right? Partially contacted. That type of problem you want to solve.
Yes.
Is it? Or you want the 4 slab fingerprint data? I'm not getting
No need of 4 slab fingerprint, but
But given segmented image, earlier problem was given segmented image, you want to add the matching scope. Last time you showed.
Yes, sir.
You want to change that one? What is that?
not going to change, sir. I am just trying to improve the existing
Improve what?
accuracy.
Who's accuracy?
Force clap fingerprint. When given, each individual finger I will calculate some score, and I want to integrate with the 4 fingers.
That case, if it is the case, why you are thinking the tilted, all those complicated things? Because then it is a very difficult problem you are touching. I don't know what you want, because force clap fingerprint, then why this type of thing? Because you have to give the pressure, otherwise it is not possible to get the image. Have you seen the force clap fingerprint? First,
I have taken.
and can you take the image by this?
Some changes will be there, na, sir. At least at the edges.
Not getting. See, the force clap fingerprints can difference between the force clap and the single fingerprint. Force clap fingerprint can make the fold to the system. Other than that, possibility. Here you have to give the force clap and give the pressure. So all has to be touched, the area will be touched, that will be scanned over. In the case of single fingerprint, you can do this one, that one, whatever you are doing. Right? So that issue will not be there. However, now you are telling that between the 2 Manisha points, you want to find out the number of reaches. If 1 Manisha point is missing, then you are in problem. Am I right? There is no problem.
I will not, and I am calculating it just only for existing Manisha points, sir.
Hello.
For
There is
each.
existing Manisha point, there is the lines, right?
Yes.
The number of lines will be computed,
Yes, sir.
and in the second image, that Manisha point is missing.
Then I will ignore the Manisha point.
How? How you know that there is missing, that is not missing?
I will see the orientation. For suppose this Manisha point is something like this, and it has one more Manisha point here, the third Manisha point. 3 Manisha neighbors to it. And I have only 2 Manisha point neighbors to it. So I will check if these 3 are same, the distance between this and this, and then this is matching with this Manisha point. Then I will check this. There is some rotation. So this point is not existent here. This
Maybe in problem. Swamiji, my suggestion would be, I don't know what are the interest for.
I will in the single finger. So whatever what he said that you have to develop a system by which given 2 fingerprint images, drop fingerprint images, it will be giving a score. And then given the 4 images, then you can fuse to get the better
Yeah,
quality.
that is the best one. You forget about those complicated ones. You use a NIST algorithm, right? Get the matching score. Say there are a lot of very large database in there. Say 500 on 500 data you test it, get the accuracy of each finger. That accuracy, suppose you got an accuracy is A1, A2, A3, and so on. So you have to fuse now, fuse means you have to give weightage on that. So A1 divided by sum of all is, you do the weightage on this. A2 by sum of all the weights is the weight of this, and so on. Then you combine. That is the thing I think will be better, simple model for it. See, what you are telling that you will not be able to solve in this as a task. That is a bigger problem. But if you can solve it, I don't know it go. Okay? You have to do it little, you are running slow. Or people are meet on this regularly.
You are working with the innovations.
So I am working on image quality assessment.
He is working on
Information. So these are the different quality parameters. So I have included these 3 new parameters.
So these three parameters I am introducing you, and I am also considering the order of calculation of different quality parameters, because the specular reflection part can affect the defocus part. Let's in iris image some specular reflection is, and then there will be some high intensity points. And then while considering the defocus, I will not consider this point. And also during the calculation of contrast and illumination, these intensities are false because of the specular reflection. So for the specular reflection, so for the occlusion, I am using the occlusion. I am not calculating the yes. So this is the input normalized image, and let's say this is some occlusion mask. Then I will subtract this image from this, and I will get some. So I will ignore these points in this image while calculating the specular reflection, and the specular reflection can be calculated by. This is the defocus part. I will call no.
This part is defocus same as the.
But I am considering the image after removing occlusion and specular reflection.
Defocus is the same, but not you are changing.
No, algorithm is same, but the
mask
image.
is changed.
Huh?
This mask is different.
No, this mask is same.
Okay, so what do you have?
The input image he has considered.
Okay. So are you sure? So you are saying that you will be using this mask over the image, which is the normalized image, and masked by the occlusion mask.
Yes.
Right?
And the specular
And
reflection.
he has not done this thing.
No, he has considered because
The
of
normalized image.
no, in the normalized image he has considered only this lower half of the iris for the calculation of defocus. But we can improve this by he has considered this half.
Fine. So how you show that your defocus you are using, and you are using the same code but in a different image. You are proposing that it will be better. Now how you will show that it will be better?
Because sir, if you have some occlusion here.
That I understood. You are justifying this. I am saying that at last you will be having the results of unweighted or unweighted code you will have.
No,
I will provide that. That's not a problem. Then you will have to show that this one, your thing is better than better giving you the better results than the unweighted.
yes. But I am
theoretically, theoretically, so that's what you are saying, that you are using all of those parameters, but applying it in normalized
minus occlusion minus
not up to minus, that's normalized and
ignoring
masked
those
by the
masked by the occlusion and this specular reflection also.
and circular reflection also. Rest of the thing, I mean the defocus.
We can also consider simply this region and this region ignore, then we can if we don't
two sectors, two non-occluded sectors, I think.
if we do not want to depend on occlusion mask and reflection mask, then we can go by considering only these two sections. But since we have occlusion, then we can the contrast and illusion is thick. This is a new part, ascending one. The pupil and iris are not always considered. There is some distance. The higher the distance between these 2 points, the lower will be the quality of view. This is
higher and lower, you know that lower will be the quality. As you said, it's not that so simple. So you have 2 points. There always be some distance between them. Now you have to normalize it. you can say that higher is the quality, the lower is the distance. Now higher and lower, these are the two terms which are relative. So relative to what? You have to find out what is the maximum and what is the minimum. Yeah.
While segmenting, while identifying the iris boundary and pupil boundary, we have considered the pupil center and 10 cos plane. We have considered.
Yes.
So that will be the minimum and maximum.
Yes.
So
in this way, okay. So in this way, you can normalize this thing to 0 and 1. So you will be saying that if the distance between the pupil center and the iris center is this, then this eccentric distance measure value will be this.
If they are exactly considering that it is the best, and it is 10, then
10.
In our segmentation it cannot be greater than the 10.
So 0 to 10. So whatever you get, you divide it by 10, and then you will be getting between 0 and 1. Right? Okay.
This is the angular assessment part.
One more thing. Let's go to the previous slide. For this, I wanted to see when you will be presenting finally, you will be showing us at least 5 best images, 5 mid-range images, and 5 worst images with respect to this time.
Okay. For which the distance is
Yes.
less.
For which the distance
This minimum, average, and the maximum.
Yes.
This is the angular assessment part.
And one more thing, that in the previous slide, in this, when you, it's my suggestion that if you see that the distance between both of these is a bit, say, 5 or 6, and the images where the distance is, say, 2, and you are saying that distance between 2, those images are better. But visually, if you see the full circular images, it won't be evident. If you see the normalized,
texture,
normalized
it will affect the texture.
See, when you are taking a full image, it won't be affecting much. But when you are normalizing it, normalization assumes that both of these centers are coinciding. But that assumption is failed, and it's failed by this parameter. So that's what I am saying, that when you are showing the 5 best images, show the full image and also the normalized images. And the distortions can be seen in the normalized images because normalization will not be properly working for those images where this xt minus xp and yt minus yp.
We can also do the recognition part. How will it is affecting the recognition part?
Later it can be done, but visually, as far as I am saying it, visually, if you wanted to say that this image is better than this, the full image you won't be able to say, but on normalized images you can say. Yeah, it can be seen.
This is the angular assessment. I have not identified how it will affect, but I have read a paper where they are suggesting this.
And you are thinking about find out the
angle. There can be the thing that the pupil is like this, and the iris part is like this. So the angle between.
So how you quantize this angle? That is the thing that you will have to think about. That once you have got the pupil center, you have got the iris center. These are the 2 points.
No, the angle can be from 0 to 180, but I am reading about how it will affect. If it is 0, then it is better, or if it is 45.
How to quantize? That's what I am saying. How to quantize? You will get some value. You will have to quantize, make it some value between 0 and 1.
Yes.
So you will have to quantize it and normalize it also in between 0 to 1.
This is the another part.
This is important.
So while the segmentation, this is the off-angle image. We have clearly seen that these 2 parts are not circular. These are ellipse. Will be considered as the off-angle.
Eccentricity you will calculate in the eccentricity of the ellipse.
No, eccentricity. No, I am considering the major axis of this ellipse. Ratio of minor axis of this ellipse. The length of this part divided by length of this part. will be giving me the off angle. So
you will fitting two ellipses, try to fit two ellipses on these images rather than the.
And I will since this boundary is due to opposite is not clearly, I am approximating the for this is this divided by this divided by. We can approximate since because this what two boundaries will be elliptical. If it is image is taken at off angle, then both will be elliptical.
So you will be getting B by A for the inner ellipse and B by A for the outer ellipse.
B by A for the outer image calculate we have from segmentation we are getting circular images.
Yeah.
But elliptical images
They are there, but
no.
we are assuming.
We are not trying. We will not be able to find the elliptical boundaries. So we since this part is not occluded, we can find the elliptical boundary of this part originally. So by one circle under 15, if we take the radius of these two circles, then this can give us the approximate boundary. This can give us the ratio of B by A.
For the inner, you calculate B by A.
Yes.
And by that you try to assess whether it is off angle.
Yes, sir.
Off
Yes,
angle, then by what angle?
Yes. No. Angle, it is not on the sense it is angle, but it is never.
It will tell you proportional to the angle. It will proportional to the
Yes.
angle. So if the images are off angle, then they are not properly normalized. And that is the thing that when we assume that it is circular, and then because of that normalization is happening. So because there is stretching and things.
So while segmentation, I am getting the two centers and two radius. So let's say this is the quantity we should be getting, but let's say you are getting some and for the inner, let's say so this radius is known to us. So I will increase this radius step. First I threshold it. Then I will increase this radius step by step. When the inner circle, we want to calculate the radius of inner circle. We want to calculate the inner radius, inner circle and the outer circle, fitting this ellipse. So
inner you have, but it is not correct. So you increment it by
the radius we have got from segmentation. It is we do not know that it is the radius of the inner circle. It can be in between the inner and major, and it can be yes, it can be higher than the major. So if we threshold it, since these points are high, low intensity, this all become 1 and this all become 0 after binarizing. Yes, sir. So at the radius we are getting from the reduction, we calculate the number of points at that radius. So the number of points with low intensity at that radius will be
you have to formalize it properly, because that is the important thing. Think about it. But after completion of the code of this off angle, I want to see that what are the images that you are suggesting these are off angle.
yes, sir.
And whether it is correct.
Good morning everyone. My project is on multi-feature iris recognition scheme. So this basically the paper basically advice of using two schemes. One is the LPP or the local binary patterns, and other one is BLOB or the binary large objects. So there will
If someone is doing on recognition and given a so they
So,
Yes, yes.
so basically, do I need to explain the local event?
You tell us now where you are.
So the paper actually for BLOB, the paper gives us two choices. One is fusion and one is chaining. That I want to explain. In fusion, you create first a space scale pyramid and then take the maximum of each entry and then match this matrix with all other images. And in chaining, what you do is you chain all these matrices and then for all the chain matrices, yeah, you concatenate all these matrices and then compare it with other images. So this is the basic difference. This is the approach which I have taken. So first LBP, we draw the LBP histograms of image, but for in this paper it is advised that if this is the ideal image, you must break it into 5 horizontal strips, and then for each individual strip you compare it with that only strip of other image. So if this is the strip, then it would be compared with this strip, and also take its value according to how many noise the ratio of the noise pixels in this image. So if this H is the histogram and K is the histogram of this image, then it will be some any histogram similarity measure into 1 minus ratio of noise pixels. This is the basically the
H and K are the LBP histograms.
LBP histograms. And then I have used uniform mapping and Bhattacharya similarity measure. For block fusion also you take first the Laplacian of Gaussian, then space you create a space scale pyramid and take maximum of each entry in case of fusion, and in case of chaining you just concatenate it and match it. So I have read these two papers by noisy iris recognition theater scheme and local feature extraction for iris recognition with automatic scale selection. And I have implemented it, but just the curves are left out.
So you have got a function by which if I give you 2 images, you will be returning me the score.
Yeah.
Up to this you have.
Yeah. I have made that file also. This is basically, and one thing I just that I wanted to propose, that in this paper they are breaking it into blocks, and the individual blocks we are getting the LBP histograms, and we are comparing these will be comparing all these blocks sequentially with the other blocks of other images. So what we can do is, we can also from the midpoint of this we can create this red blocks. As you can see, we can create these blocks, and the main advantage of this would be that for this part, if some noise is there in this part, then it will be in this part, then this part won't be neglected from that bigger block. So this that is what. Thank you.
No, but see, one thing, what you were doing is doing one block for every other point, right? One block to block.
Block to block.
So first block will be working, there is a shift.
If there is a shift in the Hamming, while calculating the Hamming distance, there is we can take some offset, and like for the shift and
for this block he has got a feature 0, 1, and for this block here he has got a feature 0, 1. But and you match by rotating.
Rotating means taking shifting the pixels of the image and something like this. Like while calculating the Hamming distance, we always keep an offset that circularly. Yeah.
Right. So it cannot be the first block, cannot be done. There is no need of many first block to the last block. Shifting means there is a limit to it.
Yes.
Right. You do not need to shift
The blocks.
too many blocks.
Yeah.
Small thing what I was thinking that this is required. See, first thing is the horizontal distance. Why do you need horizontal distance? It's a very complex product. Disperse distance is very complex.
Yeah.
Why do you need is it there?
But we can calculate correlation and everything like that also.
Simpler one, because such a you can check the horizontal distance is required or not. Second thing is that you feel that it is what to have the registration of the two images. Sometimes acting is required to register the data and then.
If it is registered, then the results will be better, of course.
So registration will be careful. Because beauty of this is there is a this type of design is there. So the design you
No, I have
design
the result. Fine.
on ID setup?
Yes.
You have results
On
which database?
IIT. Just first time. No, I told
Some
him it's running.
50,
Yeah.
suggested to use some 50 subjects right
Yeah, yeah.
test.
Yes.
Now you will have to test rigorously on the whole
Whole
database,
database.
on all these 3-4 databases and then the graphs and all. It will take time.
Yeah.
And also you will have to give the parameters because whatever parameters you have fixed right now, there are several parameters. So it will be giving you some accuracy, but if you change then the accuracy will also be changed. So you require the best parameters out of it all.
So good morning everyone. Our project topic is finger knuckle recognition and quality parameters. So the approach is that we will use 6 bits approach. We will use the 6 bits. The first 3 bits will be derived from the Rees transform, second order Rees transform, and the last 3 bits will be derived from COM code. For deriving the COM code, we will be using the Gabor real part function, and for using the Rees transform, first we will have to use the filter. We will first use the filter before applying the Rees transform, and then we calculate the Hamming distance by extracting the features of the 6 bits. And if the distance between them is, we haven't set the threshold yet, and if the threshold is, the score is less than the threshold, then we can say that the image is matched.
So tell me one thing, why 6?
6 bits. In the paper it is given that by using the 6 bits, the result we get is the best.
For recognition also I have given them the David and the recent paper, so in which previously they have used only 3 bits, the COM code bits. Then they have proposed 3 more bits, the Rees code bits, and then they have fused both of these, and then have shown that it's better.
Are you using the bit? Are you putting the bit by small, 1 by 1 by 1?
In bitwise.
You are using 1 by 1 by 1 by 1. So every time you are using 2 bits.
So we are storing them as a value 0101.
So you are storing the bitwise?
No sir, in a matrix.
We store images as a matrix.
And then the size will be more. So what Sir is saying that then the size will be more. If you save these 6 bits as individual bits, because see that if you place 1 as an integer, then it will take say 8 bytes. Even this 1 is taking 8 bytes. But within that 8 byte you can 8 bit you can save 6 bit whatever you want. And what he is saying that 2 bits even though you will be losing 2 bits. So you can save all this thing in a single bit structure, array of basically bits, place whatever you want. So that is the optimization that you can do.
But you will be doing the Hamming distance only. So why do you think all zeros will come and match? That's not required. That will show you, say, already assured 25% match. Am I right or not? 2 bits, zeros in everywhere.
So that won't be a problem. So we will not calculate that 25% because
You
what?
will be subtracting 25%.
No sir. So what we are doing that we are storing in a matrix space. So we have 6 values for one pixel. We have 6 values.
Oh.
So we calculate Hamming distance by using those 6 values.
Only one bit.
Hmm.
So you will be doing the bitwise manipulation on only designated bits.
Yes.
Am I right?
Yes sir.
That means you are storing them bitwise. Yes?
Yes sir.
So you are sure?
No sir.
Not sure.
So basically we are storing in a matrix.
You have a matrix T.
So matrix
So this T is of the Boolean matrix.
M cross
M cross.
n cross 6.
What is M?
M is the number of rows of the image.
Number of.
The most rows of the image, and n is the number of columns of the image.
And each element is a line.
No
Integer.
Integer.
We are storing n cross 6.
And each element is?
Integer.
Integer is 4 bytes.
Yes sir.
And to store 6 bits you are taking 4 bytes.
Space I think they have not optimized.
No. If you take the XOR operation, he's taking XOR operation, right? Hamming distance you got,
Yes sir.
So all operation you are doing the.
We are using the all operation.
So six
But we are
bits is a value you have taken. 6 bits is.
We are applying XOR on 6 bit only.
That's not bitwise.
Yes, sir. We are applying XOR on only 6 bit that we calculated from the image.
So and cross 6.
Yes, cross and cross 6.
And cross 6. So it is a complete. So they are saving 1 also as an integer, but when they are XORing, they are only.
We are using the 6 bit.
That's not bitwise.
No, we are doing it manually.
Time also to say if you use the bitwise.
Bitwise manipulation will be faster. So optimization you
And what is the here? What is that?
Yes, sir. Basically, the image we have given that there is a wide range of intensity. So basically, we are using bandpass filter. Yes.
And it is a
Filter using
This is just like a LOG. Measure of Gaussian is the measure of Gaussian.
it will be a real number,
It will be yes.
right?
Relative binary.
Then we will binary.
Oh, this is the number.
Sir, what we do is that we find the average of that.
There is a possibility the negative.
Yes, sir, there is a possibility. The negative values do arrive, but what we do is that we take an average of the data of the values and set at the zero crossing for a maximum minimum value. Then we find
Zero crossing, zero or
that was, so we have calculated the result here. We have on the code is taking too much time.
Who is the owner of this for you?
So we wrote in both set and both. So basically, the code is running, taking too much time. So basically, we are calculated is 3 into 3. We are calculated here for some folder. Some
Only
data,
for two
not
folders we
data.
have it. Only for the two folders here.
Folder.
We have 660 folders, and each folder we have 6 12 images.
6
Six
images, subjects, and only 2 subjects you have tested.
3.
Three on
How much it will take?
it's ran for 12 hours for the two folders. The
12 hours, you know that it's not up.
Hmm.
And they it won't take 12 hours. 12 hours you can get now. Not for 660, but at least first 100 subjects you can. So you require, as I was saying, that if you are doing operations at bit level, then use the bit level operators. Then it will be fast.
C is very good for bigger.
XOR and things. So you can do one thing, that you can save your feature whatever in the form of calculate all those things, save this. Are you computing features every time, or
Every time.
Then why you are computing it every time? You do it once and save it, and then at the time of batching you are using. That is why it's taking huge amount of time. First you save that feature. This 6 bit you are calculating every time. Suppose that you are matching this image with this, then again you match this image with this, then again you calculate of this.
Now we are storing that the value of the image of features of the first image.
Features, save all the features.
Okay.
And then whenever you are matching, you load it on it. And also, as far as saying that if
You make it a vector, not matrix. You make it a vector of size 6 into m into n. Big vector.
and then for matching you can use the C.
Yeah, see with the or big
You
vector
load
of
that thing. And that's an XOR operation. It will be very, very good.
We are using this formula.
That is the that's for the
Concord.
You have got all these parameters for count code and for reach code. Everything parameters are given in the paper. And some
In some we have searched for the paper and we got the
Yeah.
formula.
Last we done basically for code that we use Gable filter. Then the
these are the quality.
quantifiers. Basically, we can use here the coefficient of distortion to find distortion means. Suppose we are given a set of image that is difference image, and we are has given us some another image. So basically, we can compare those two images on the basis of coefficient of distortion. Means
Yes, of course. So ultimately you are using the
Yeah,
risk
it's only
transform
5
for
coefficient.
matching. So you are saying that instead of finding out the quality depending upon the image, you can also think of that how this risk transform coefficient.
yes, sir.
Can we take account of the edge part also?
Basically, we are using that 5 coefficient. So basically, what the index is finally we are obtaining is after applying some operation, we are taking multiplication of all these coefficients, and we are calculating these coefficients as varying as edge points. So basically, at all crucial points, we are calculating all these coefficients, and then we find index between two images. So we can basically check that how much distortion in image to image reference image. Okay.
How you are getting this index?
Basically, we will apply we will use KNUCKLE detector to find edges, and then we use
Over those edges you will find out these 5 parameters.
yes.
Then how you find out the index?
Yes, we use basically 4x4 structure mask, and then we will dilate the mask on whole image, and then
I think that in this way you will also be contributing or what's the quality, estimating the quality of those edges, because this and
yes.
Reach transform, these 5 parameters will be encoding the edges, because you are applying it on these edges. So yes, so that can be used. For all these parameters, and let me tell you that we wanted, at last we wanted to see that with respect to say the ridge-based distortion, what are the 5 best images, what are the 5 worst images, and what are the 5 medium level images. For every quality parameter, you have to show this thing, that what are the 5 top, second, and the mid level, and the last level.
To justify the correctness of your point.
Later we wanted to see that after fusion, fusing all of these 4 or 5 parameters, whatever you have suggested, what are the top images that you are suggesting out of the whole database, not only the 5 or 10. Out of the whole database, these are the 5 best images, these are the 5 worst images, these are the mid. Okay. So you have started coding all the quality parameters?
Yes.
You will start.
I'm sure you have enough more.
You have got the database.
Yes, sir.
What you said, can you justify RX what is equal to R like it?
Formula is symmetric.
Formula is symmetric. These formulas are RXY. We are the formula symmetric.
So this symmetric with this frequency.
Our basic what it is.
Yes, used in this way.
The value we have.
Yes.
For recognition, I have given them the paper, and for quality, they are.
Who's coming? Next. 9002. 9002, please come.
Yes.
So you will be giving us the 2 Manisha words.
First part is finding out the minutia points, and second part is constructing cylinder and finding the singularity.
How much you have?
This finding, yeah, I have presentation, but it is mainly based on the second part, on X cylinders. Finding the true minutia points, I just read some papers, and ran the code which is available in the net. I am thinking I have to.
Available in the net.
Yes, for now.
But it gives you the 2 Manisha.
False minutia points, there are mainly they will be located on the out boundary sides. False minutia points.
He has seen a code which can eliminate on the boundary side.
Yes.
they are also.
That is only one part, not
One
complete.
thing you have got the code that I will do it, or you have not.
Which one did
Where is it? Who was
Himanshu forward?
So in that, what it was doing that it find out the minutia and at the boundary, several if two minutia are very close to each other. So the student minutia are. As I said that you read that code and try to understand what are the cases that code is handling and what are some more cases that you can handle in that for the experience. And then I think after that you have done with that minutia cylinders.
Cylinders coding I did not start.
You wanted to show something.
It's just the algorithm that is present in that paper. No.
Yes, you have read that.
Yes, means yeah, I have read and yeah, that's what.
You have also met with them.
Yes, yeah, I have met him. It is not still clear which I will do and which Himanshu will do.
So what is the thing that he and you, they both wanted to code this minutia cylinders code. I have said that as you have also suggested that up to this part he will be doing and after that he can. So both work. Okay, that's fine. So up to minutia extraction. So basically your work will now be to find out the correct minutia, right?
Yes.
And then he'll be coding the cylinders and matching.
Yes.
Cylinders and matching here. What
If it is, means I don't know if minutia extraction is big or small. If it is small, I will also work with him in
no, we want the correct minutia.
true minutia points. Yes.
That is important because you will be getting not only the spurious minutia on the boundaries, you will be getting huge amount of minutia which are spurious and giving the.
You will be some of the true minutia.
Yes. So from you will now be expected that given a fingerprint, you will be returning the minutia and now ensuring that these are the true minutia. And then after that, he will be doing the minutia cylinders and similarity basically matching. Right? Then both of these things can go, both of you are working on MATLAB, so it can be used. So ultimately you will be getting a system in which I will be giving a two images and I will be giving this to the person. You can also comment. Himanshu Singh Agarwal. What is his number? YN250. So now you can, I mean, if you are working in group.
YN250 present.
Yes, I wasn't present in the first.
So you know that, right? So consequences also known to you.
Yes.
But how can you tell that you are not present, no, on any complaint? Because you are, say, I know this problem now is becoming little difficult. And what he studied cylinder.
Sir, I have also studied the cylinder.
Sir, what I am saying that now they both can work together. As I have said that you both work together and we want a system in which we plug in. It doesn't matter that you have coded the minutia or he has coded the minutia part or the other. At last we want that given two fingerprint images, we will be giving you the score based on the true minutia and using the minutia cylinder code. That will be the thing. So you both work together. I think that you both know each other. And you have also got the database. I have sent you to Virendra. You have got that thing also and some rough this MATLAB code that I have also given. So you can use that and they both can do it.
For now, we both have presentation of just cylinders.
That's fine. So whoever wants to present can.
I will present. So my problem statement is that I will be given segmented images. It's basically post-lab fingerprint recognition.
This slide is
F5.
Yeah, so I'm using this approach, minutia single code. Input to this algorithm is the minutia template, where each minutia point consists of x coordinate, y coordinate, and the orientation. So first of all, I'll calculate a local similarity between each pair of minutia by constructing a cylinder around it, and then I'll use the local similarity scores to obtain a global score. So the local structure of the cylinder of the minutia is represented by a cylinder. It's a cylinder with cylinder has a radius r and a height 2 pi, and the cylinder is enclosed in a cuboid. The base of the cuboid is aligned according to the orientation of the minutia. Now we divide the cuboid into small compartments, that is cuboids, where we can identify each cuboid with a unique index ijk. We can define the angle for each cell, that is the cell at index k, that is height k, that will have an angle defined by this thing. It will lie between -pi to pi. Similarly, we can calculate the center point of each cell. Now, we define the neighborhood of each cell as the number of minutia points that lie within a distance of 3 sigma s from the center of the cell. So, for example, this is a cell ij. So the minutia, this is the neighborhood of the cell. The minutia points painted black are the neighborhood of the cell. For each cell, we calculate a numerical value which represents the relationship between this cell and its neighboring minutia. So this relationship is essentially the likelihood of finding the minutia near Pij with a directional difference which is close to the angle of the cell. We don't need to consider all the cells. We need to consider only the cells which lie within the convex hull determined by all the minutia in T. The convex hull is basically the smallest polygon within which we can enclose all the minutia lying within the fingerprint template. So this is just basically mathematics. Finally, we get the index. Finally, we get a score corresponding to each of the cell of the cylinder. We linearize the index to obtain in a linear array, in the 1D array. That is, now each index will be represented by a number between 0 to nc, where nc is the total number of cells. Now we compute the similarity between two cylinders by subtracting the two vectors obtained, that is the two arrays obtained from the two cylinders. We only consider those elements for which both of the cells are valid, corresponding cells are valid. And further, we assign similarity score to two cylinders if they are matchable only. They will be matchable only if the directional difference between the two minutia is not greater than a certain value. That is, we are limiting the maximum possible orientation difference between the two cylinders. Second point is that at least a certain number of minutia elements, a certain number of cells should be common in the two cylinders. Otherwise, we could have a matching based on a very small common area. Finally, we obtain the local similarity between each pair of cylinders. So finally, we'll consolidate it into a global score. The technique used will be local similarity sort with relaxation. Basic idea of this technique is that given a pair of minutia AB, if the global relationship between A and some other minutia in A is compatible with the global relationship between B and the corresponding minutia in B, then the relationship between A and B is present, otherwise it is weakened. So this algorithm basically describes the same thing. Yes, sir.
The way he is presenting, current based करके लगा दिया.
At least you understood all of this.
Yeah, I have understood.
Because I have also attached both of them.
But you see this presentation material is just taken from the current based
I have understood, but so it's too mathematical, it's hard to explain in the presentation.
I don't have any problem.
sir, I'll consolidate the individual scores into globals.
I don't know. You can do it. I have to know. Because I am little afraid. See the next slide. Next slide. See. Yes, just checking from the text. Got it?
These are the papers that I read.
But long way to go for both of it. Right? How you have to do it? The sound is coming. So today at 5, what time will you be? 5.